Okay, so today I'm solving for the minimum force needed to lift a 98 kilogram box at a constant velocity using a two pulley system. And here is all my work for this. So, first I wanted to share the big ideas. Um, and one of them is equilibrium because the velocity is constant. So that means the net force must be zero. And then mechanical advantage is another big idea of this problem, and it's because we're using a machine to trade pull distance for a reduction in the force. And then, so my physics approach is to focus on the movable pulley, which is the lower one with the hook mainly connected to the box with the two rope segments. And in the ideal systems like this, tension is uniform throughout the rope, so it's all the same. By defining the box in the lower pulley as my system, I can see how many segments of rope are fighting the gravity. So it's two of them. And this is mainly on the relationship between tension and gravity. And everything with mass is pulled towards Earth. We know that. So to move it up, we must provide an equal or a greater force in the opposite direction. So by looping the rope on the lower pulley, we distributed the total weight across multiple support pillars, which is the rope segments, you could also say. So when solving for so finding weight, first I need to find the downward force. So as you can see here in my work, to calculate the force of gravity, I did the Fg equals mass times gravity. So that would be 98 kilograms times 9.8 meters per second squared. And that will give me the force of gravity is 960.4 newtons. So gravity is pulling the box down 960.4 newtons. So looking at the diagram, there's the two rope segments pulling up the box. So this means that my tension is going to be doubled, which it's an upward force equals 2T, 2 tension. And once again, with Newton's second law, since the box is moving at a constant velocity, like the problem says, net force must be zero. So I put the sigma force equals zero. And to find the tension, the equation is 2T equals the force of gravity. So we're finding the F pull. So it's T is equal to, tension is equal to the force of gravity divided by 2. So then the tension would be 960.4 newtons, which we found, divided by 2. So that would give us 480.2 newtons. So that would mean that the minimum force required to lift the box at a constant velocity is 480.2 newtons. And then I just drew the diagram on my iPad so that I could just have it there. So because of our big idea of equilibrium, that's why I set the upward forces equal to the downward weight. So the 2T equals the 960.4 newtons. And then you just have to swap the equation around to be able to divide the force of gravity by 2. And then by analyzing the forces, we see that the movable pulley splits the weight of 98 kilogram box between two segments of rope. This gives us a mechanical advantage of 2. We first converted the mass to a weight of 960.4 newtons, then determined that since two ropes support the load, we only need to provide half of that force.